Hey guys, hope you're doing okay today. I'd like to start a new unit with this video. In this unit we're going to be talking about confidence intervals and hypothesis testing. This will be one of the last units that we cover for the semester. First confidence interval I want to talk about is a confidence interval for the population proportion. Now, we talked about being able to describe the distribution of the sample proportion. We said if we just kept on taking a bunch of different samples, how everything became normally distributed. We did this with I think that was like the 42% of people that lived in haunted houses. And as our sample size got bigger and bigger and bigger, we saw that everything became more and more normally distributed. And I want to use that idea to help me construct something called a confidence interval. Okay, so a couple of words you're going to hear me be talking about. First of all, we're going to need to be able to get a point estimate, right? A point estimate, if you remember, is going to be right in the middle of my, that's a terrible bell-shaped curve. It is pretty early in the morning when I'm making this, and so you'll just have to bear with me a couple times in this. But my point estimate, p hat, is going to be right here in the middle of my bell-shaped curve. Okay, and so that's where my 42% of people that would live in a haunted house or would not live in a haunted house, whichever way it went, that's where that would be. Now, based off that confidence interval, or the point estimate, what I can do is I can go out so far from the center. I'm not really worried about as many standard deviations on this. You'll kind of see where that comes into play. But the idea is that I'm going to want a level of confidence that will be between these two numbers. I'm going to call them A and B. I probably won't call them A and B again. But between these two numbers, A and B, I'm wanting a certain percentage of my samples or even my population to lie between there. 95's a pretty big one that we use. So a 95% level of confidence is always good. And so we're going to talk about in this video how to get my hands on these two values, A and B, that will set up a confidence interval, which is going to estimate my population proportion. If I was able to get my hands on the entire population, how they would feel about living in a haunted house. Now, just so we're on the same page with this, I'm not going to erase that. I know it's over my writing. I apologize. If I'm taking a 95% level of confidence, and sometimes you'll see it written as alpha equals 0.05, that's your margin of error right there. And that implies that if I was to go out and do 100 different confidence intervals, then it says each based on a different sample from the same population, I would expect 95 of the intervals to contain the parameter and 5 to not include the parameter. So suppose that, I'm just going to make up some numbers. I don't even know if this would even be close to true with what we had, but suppose that I found A and B to be 0.28 and, let's see what I did, and 0.56. Okay? And I say, you know what, I am 95% confident that the true population of people that would not live in a haunted house is between 28% and 56%. Now, there's always going to be some error there. Okay? There has to be, because there's always going to be area over here in these tails. So what I'm actually saying is that if I was to repeat this sampling, suppose I was to go out and ask 100 people how they feel about living in a haunted house, and I ask another 100 people, and I ask another 100 people, so much so that I'm doing this 100 times. I'm asking 100 different people 100 times how they feel about living in a haunted house. I would expect 95 samples out of that 100 to lie between these two values. Okay? I'm geeking out a little bit early on this. I apologize for it, but this is stuff that gets pretty exciting right here, I think. So we have some math that we're going to have to do with this. Okay? These are going to be very crucial formulas for us. And so Yeah, let's get these on top of our homework page. Let's get this on a note card wherever we need this. Okay, if we come back, again, if we come back to school, you can definitely expect to see this written on the board. I know it's on the formula sheet that SEMO gives for the final, so nothing I'm wanting you to memorize right there. Rather, just know how to use. So it says, suppose that a simple random sample of size n is taken from a population, then a whatever percent confidence interval for p is given, for the population p, is given by the following quantities. So to get my lower bound, I'm going to be taking my point estimate. That's what this stands for. And then I'm going to subtract off, or I'm going to add down here, I'm going to add off this z value. Well, we're going to get this right off of our favorite table that we have been using. All right, so get that thing handy. I might try to find it online and post a picture of it with all my class materials for this lesson in case you've lost it somewhere. If not, I'll scan mine and put it on there. Okay, and then from here, this should all look familiar to you because this is just my standard deviation formula that we had in the last unit for the distribution of my sample population or proportion. And so that's still the same. So I'm still just going to bring over my point estimate, whatever I find. I'm going to put it here, and then 1 minus my proportion, put it here, and then it's all over n. And I think you guys are good on this. N is still going to be my sample size. Now, something that the book hits hard on is, I don't know if I'm going to teach it this way or not. We'll just kind of see how it goes. But the book hits hard on the fact, just the part that comes after that plus or minus. This z, I'm going to write this in red so I can see it, because I'm going to need it up here as well. This z sub alpha over 2 times p hat times 1 minus p hat all over n. Okay? And they're going to call it the EBP. Okay? The EBP. So the error bound for a proportion. We're going to play with that more in the next video, but as you can see, that's just going to be my error bound. That's how far to the left and to the right of my point estimate I can go and still have and still be within my confidence interval. Okay? And so let's plug in some numbers. Let's see how this works. I'm probably way over teaching this and confusing you, so let's just throw in some numbers and try to figure out what's going on here. Okay, so suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people, 421 responded yes, they own cell phones. And so I want to use a 95% confidence level. I want to compute a confidence interval estimate for the true proportion of adult residents of the city who have cell phones. It is going to be next to impossible for me to go out and ask everybody in this large city if they have a cell phone. Okay, by the time I ask the first person and I get to the last person and ask them if they have a cell phone, and that first person responds no, and I finally, days, weeks, months later, get to the last person and say, do you have a cell phone? That first person might have changed their mind and went and bought a cell phone. And so this is just going to be too hard to get my hands on everybody, every adult in the city to figure out if they do or not. And so here's what kind of goes on in my head whenever I look at this. Now, first of all, I need a p hat. Okay, my p hat. We'll switch colors so I run into my formula up there. My p hat, my point estimate. I also call it just my snapshot. All right, so I just took one estimate of this. I found that 421 out of 500 people own a cell phone. I'm having to grab my calculator real quick. It's all the way back by my desk. And so whenever I put this in, 421 divided by 500, I get 0.842. So in my little snapshot right here of this little survey that I did, I found that 84.2% of residents in this city own a cell phone. Now, again, I might overteach this. I'm going to go back to my curve, see what this means. That means that right here in this middle, right here, is 0.842. Okay, 0.842. And so, if I'm using my formulas from that last slide, let's see, it had the point estimate, right? Plus or minus my error bound. And so I'm wanting to take this 0.842 that I found, and I'm going to do plus or minus. Ooh, I'm just going to leave this blank for a second. All right, that's z-score. But I know a lot of this formula just from plugging it in off the top right here. So I'm going to have 0.842. That's the probability someone does have a cell phone. And then I'm going to do 1 minus that. That is going to be the probability that someone does not have a cell phone. I got 15.8% on that, over the 500 people that I surveyed. So what's this guy doing right here? Right, this z sub alpha over 2. Let's talk about what that means. Okay, remember I said that alpha. Let's see which way I want to go with this. Remember, I'm wanting to make it so that I have 95% of people right here in the middle. That's my best guess as to where my population proportion lies. It's somewhere between these two black lines. And so if I am eating 95% of my area underneath the curve right there, that leaves these tails over here, two congruent tails that are going to have the rest of the 5%. And so that leaves 2.5% in this tail, and that leaves 2.5% in this tail. And that's exactly where this alpha over 2 right here comes from. Okay? This alpha over 2 just means that if I'm doing a 95% confidence interval, it means my alpha is 5%. Okay? That's how much area I have over here in these tails. And so if I divide everything by 2, I get alpha equals 0.025. So if I divide that by 2. And so this alpha over 2 just means that I'm just going the area from one of these tails. And so I'm going to have to go back to my table on this. I think it's going to be easier to find the area from this tail right here. Because if you remember, on my z-chart, which I've got coming up, I'm probably going to move. Yep. If you remember my z-chart, it loves area to the left. All right? It absolutely loves area to the left. And so I'm going to pick on this area to the left that was over here. And that is my area. So I'm wanting to find this 0.025 over here in the bulk of my table. All right? And yeah, it just kind of jumped out at me right here. And I'm wanting the z-score that goes with it. And the z-score that went with it was negative 1.96. Now the good news is you said, well, I would have done the other tail, Mr. Lovelady. That's fine. If I would have done the other tail, I have 95% here. And so if I have 95% and 2.5%, that makes it so this whole area right here is 97.5%. I barely got it on the table right here. And look what it gave me. 1.9, then there is a 0.06 here. It's not letting me write up here, but there's a 0.06. And so this would have been 1.96 on this side. So that's why it has the plus or minus, because we can use either the positive or the negative. Okay, so we're ready to bring that 1.96 over. To this. And so that plus or minus, I already got the plus or minus built in right here, 1.96. Okay. I've got a DHS easy button for you. I just don't have it, anybody here to hit it. I'm afraid I'm going to forget it, so I'm going to tell it to you in just a minute. So now I just have this massive calculator problem. I'm gonna keep like, it looks like 3 decimal places. It looks like it's something good to keep on this. So I just have all this to type in my calculator. 0.842 times 0.158. I'm dividing all that by 500. I got something incredibly small. When I take the square root of that, it should get bigger, and I'll multiply it by 1.96. And it's still going to stay small. Okay, so this error bound that comes after it was 0.032. Okay, and so my confidence interval is going to be 0.842 plus or minus this. So let's do 0.842 minus 0.032. So 0.081. And then I'm going to do 0.842 plus this confidence interval. 0.842 plus 0.032. 0.874. And that's how we write confidence intervals. We write it as just a little interval. Before I wrap this up, I did want to show you a DHS easy button on this, how to get this 1.96. Actually, you know what? Just remind me, I'm going to show you that later. All right? I'm going to show you that on the next example. Just keep in mind that we got 1.96 right there. Now, wrapping this up, I have every confidence interval that you will find for me. You need to wrap it up with a sentence, an interpretation, if you will. Whether the problem asks for it or not, I need an interpretation. Okay? And again, I love the interpretations whenever you act like you're trying to describe what's going on to your mother. Okay? And so I like to use my number right here, and that's how I started off. Okay? So it's kind of a blanket one. We are 95% confident. And make sure in your interpretation you're using words from the problem that the proportion, maybe even say population proportion, of adults in this city who have a cell phone is between, we'll just say this 0.810, between 0.81 and 0.874. And that is a great sentence to wrap this up with. I love it. So remember, whenever at the beginning of the problem I said it's going to be impossible for me to get my hands on every adult and ask them whether or not they have a cell phone. Okay? What I can now say, I'm not going to be able to say this ever with 100% right here. It's never going to be 100%. But I can say that I'm 95% confident that if I was to ask everybody in this city if they had a cell phone, that the number of people that would say yes, they do have a cell phone would be between those two numbers. Okay? So whenever you're dealing with these populations like we're going to be talking about over this next week, we're going to have confidence intervals with it. And there's so many different ways to do the confidence intervals, and we're just going to focus on just a few of them. Hang on to that 1.96. I know, you're probably like on the edge of your seat. You might have already fast forwarded the video and saw the DHS easy button, but you're just going to have to hold on to it a little bit longer if you're not willing to hit fast forward. I did a lot of stuff here. I did a whole lot of stuff. And so normally this is where I would say turn to your PodBot and work out this problem, okay? And I'd go around the room and help you. But since we are social distancing, you're probably not close to a PodBot. If you are, feel free to pause this video and then fast forward to the end, get the DHS easy button, and work it out. All right? If not, then we've got to go forward with it. All right? And you have to watch me work all over it again. So this time we're talking about a tablet, not in the town, just adults. Is it adults? People, just people who have a tablet. Okay, and so again, I got to start off with my point estimate. And man, I erased my error bound up here. I'm going to put this back up here. Z sub alpha over 2. I need it more than you do, I think. I think you've already got it down. Okay, so first up, I've got to get my point estimate. Okay, and so my little snapshot right here of these 250 people that own a tablet, only 98 do, and so 98 out of 250, 0.392, 39.2% of the tablet. That's my best guess, but I'm not very confident in this guess. I'm not very confident at all. And so I'm going to draw my curve. I know that right here in the middle, my best guess is 39.2% of people. Now this time, I'm just going to use a 90% confidence interval. Look what that's going to do. That is going to suck in my sides a little bit. It's going to make it so I'm not as far over in the tail, so that 90%, okay? I'm wanting all this area in here. Those will be my best guesses for the true population that have a tablet. But what does that mean for my alpha over 2? Okay? That means that my alpha is 10%. That means that there's 10% down here in these tails. And since they're evenly distributed, that means that there's 5% down here this time, and that there's 5% over here. I've got a lot of my information. I've got some stuff I need to do on the table. All right, but I'm going to go ahead and get this started. I've got my point estimate, 0.392, plus or minus. I want to go ahead and find the alpha from my table. So let's see. I'm wanting to use, I've got plus or minus happening right there. I'm going to use this, this 5%. Okay, so I'm going to go back to my table, erase all this. It's going to be in the way. Some of it won't erase. That's great. Try to erase it. Erase all this. And I'm wanting to find 5% in here. Okay? I want you to go ahead and find 5%, and I'll show you where I found it. Uh-oh. Which one do we pick? The answer is yes. We want to go halfway between. But guess what? So this is negative. I don't have the top of my table right here. So 0, 1, 2, 3, 4, and 5. Negative 1.6. I want to go halfway between negative 1.64 and negative 1.65. So add these up in the calculator, divide by 2. I'm going to bet you land here. You know what, though? I found this same number somewhere else. Now, I could hit this easy button, and you probably wouldn't be able to hear it. So here it is. Consider it hit, and then I found it. Okay. I'm making this a lot harder. All right, there we go. I found it down here. There are specific Z sub alpha over 2 values that we use over and over again in statistics. One of them being, I told you, 1.96. So remember the last problem where we did a 95% confidence interval? There's this 1.96. I can just come down here to the bottom of the table and find it. Well, just like we're seeing in this problem, 90% confidence interval is very prevalent too. And sure enough, I have the 1.645. In your homework, it might ask you to do a 98% confidence interval. Boom, there's the Z value right off the table, all right? And so there you go, a little bit of an easy button for you in this video. All right, but I want to go back now. I got my 1.645. I'm wanting to, let's go back to this. And, we're already in present. And so my z sub alpha over 2 came out to 1.645. From here, I just got to plug everything in. So I expect 39.2% of people to have a tablet. And so people that don't have a tablet, 1 minus that 0.392, 60.8%. Struggling. Don't have a tablet. Okay? And that was out of 250 people. And you just have this massive calculator problem again. And I like to bring down my 0.392, and then I calculate this error bound all in one swoop. Okay, I do some of you are really good at making your calculator screen look like that. Kudos to you. So I got 0.392 times 0.608. I'm going to divide that by 250, and you're always going to get something incredibly small here because we're working with these proportions. We're working with all these numbers less than 1. But whenever I take the square root of that answer, it's going to grow a little bit, and I'll multiply it by my z value, 1.645. And so my error bound, I'm just going to do 3 decimal places, 0.051. Okay. So back up here to my curve, that means I'm willing to go 0.051 out this way, and I'm willing to go 0.051 out this way to get my new numbers. Okay? And so those numbers would be, let's do 0.392 minus 0.051. 0.341. Okay. I can do 0.392 plus 0.051. That brings me up to 0.443. Good. There's the confidence interval. What does it mean? Well, it means we are, this time, 90% confident that the proportion of people who, let's see, is it use or own a tablet is between these two values, 0.341. I keep on wanting to use, it's not really wrong to use it down there, but it's kind of weird. 0.341 and 0.443. Love this box right here, and I will be reading it. I want a complete sentence. I want you using words. Act like you're describing it to your mother. Okay. Now, if you did not work that one on your own, please work some of these on your own. There's not many of them. Some of them are just setting up error bounds, I believe. Okay. And so that concludes this video. Short one to follow. I'm just going to be working with the error bound on this.